In this video, I'd like to talk to you a little bit about functions. Functions are actually a specific kind of relation. So it is sort of a subset of relations. Not every relation is a function. Some of them are. So it's a set of ordered pairs or a relation such that each x value has exactly one y value that is associated with. In other words, a function cannot have 2 points with the same x value but different y values. So it's easier to understand what's not a function. So for instance, let's say you had an example where you have x equals 3, and it goes to both y equals 5 and y equals 1. So for instance, in your graph or your equation or your set of points, you see the point 3, 1 and 3, 5. Well, this is not a function. So basically, the x values don't repeat. That's sort of the big thing that we're looking for to make things a function. Now, there's lots of things that we use that are not functions. Like, for instance, circles are not functions. So there's lots of amazing things in the world that are not functions. So don't think that you have to be a function to be useful or anything like that. It does make our life a little bit easier, though, because we know if the value is, let's say, 3, there's only one output or one answer. Whereas if you know the value is 3 and you can have multiple outputs, it just makes life a little bit more complicated. So there's nothing wrong with things that aren't functions. They're just oftentimes a little bit harder to deal with. And you have to be a little bit more careful about because you could have multiple outputs for the same value. So for instance, if I look at a basic example here, determine if the following is a function. Let's look at the set of points. -1, 1, 2, 3, 7, 3, and 8, 6 as my first example. So if I go through here, I look at my x values. I see x is -1, x is 2, x is 7, x is 8. Those are all different x values. There are no x values that are repeating there. So this is a function. Notice that the y values do repeat, and that does not affect the definition. Neither would a point like if I had 2, well, not 2 here, but maybe like 5, 5. X equals 5 does not appear here, so it's not an issue. Like within the same point, the y values don't really matter for this definition. We do have stronger definitions later on in mathematics, where if neither x or y repeats, we call that a one-to-one function, so it's a bit stronger. But for the definition, you're just looking at, are the x values repeating? Or if I give you an example like this, so here my x values are 0, 1, 0, and 7. Notice that I'm seeing x equals 0 twice, and then it has 2 different y values though, right? It's not like it's the same point. They're 2 different points. This one has a -2, this one has a 3. So that is making it not a function. The 7, 7 is actually perfectly fine. There's no other 7 for the x value, so that the y's don't matter here for the definition. It would just be the x values. So this is not a function. I'm just going to abbreviate function fn because your x values repeat, right? And they have different y values with them. That's the key. So not only does the value repeat, but it goes to different y's. So it just makes things much more complicated. Now, this is a very basic example. So when you have a table or a set of ordered pairs, it's pretty quick to figure out right away if you have a function or not. It gets more complicated if you have a graph, though. So we have something for graphs called the vertical line test. And it basically says the following. if a vertical line can be drawn through a graph such that it hits the graph more than once, the graph is not a function. So let me show you a few examples here. All right, we'll start with 4 and then we'll see if that's good. So let's do our first picture here. I'm just going to do a line. This one, I'm going to do a U shape. This one, I'm going to do a sideways U shape. This one, I'm going to do a couple of points here. One there, one there, one there, one there. All right, this one, I'm going to do a couple more points. And then this one, I'm going to do a vertical line. Okay, so let's go back up to the beginning here. So the vertical line test, you're looking to see if it's possible to draw a vertical line through that hits more than once. It doesn't have to occur multiple times. It just has to work one time. So for instance, if I draw vertical lines through this graph here, well, this one only hits it once. I can't see anywhere to draw a vertical line that would hit my graph more than once, right? So something like this is a function. Right? I can't get a vertical line that hits more than once. Let's try it with B. All right, I draw it here, I hit once. Here I hit once, here I hit once. Again, I can't see anywhere that I can put this line that's going to hit more than once. So this is a function. For the next example, though, notice what happens. If I put a line here, it's fine. It hits no time. So if I put a line here, it hits once. If I put a line anywhere else on the right, it's going to hit the graph twice within the same line. That is not a function. And the reason it is not a function is because what's happening is as follows. So for instance, like let's say this is, we'll say 1, 2, 3, maybe this is 4. Maybe this is 0.2 and -2. What happens is at x equals 4, you're going to two different values. You have one value above it and you have one value below it. So you're getting that repeat x there. So that's why that vertical line test is working. For the next one, I have 4 points in my graph. If I put a vertical line through any of these points, it never hits more than once, right? I can put them in the middle too. It hits no times. So this is a function. In this case here, if I put a vertical line here, I'm fine. If I put one here, I'm fine. And here, I'm fine. But if I put one here, I hit this graph twice, right? Because there were 2 points above each other. So as long as I find one spot that fails, not a function. This is one of those types too, where I know we do a lot of our work online and you maybe just be looking, but I really encourage you to like draw the picture on paper or at least like kind of on the screen, just kind of like not touch the computer, but like, just kind of mimic where the line would go and just help you visually see if there's anything that's hitting more than once. Now, this last example is also not a function. So here's a vertical line. And what happens here is when you draw your vertical lines, if I were to put one exactly here, it would actually hit infinitely amount of times, right? Because there's infinite points along this line. So vertical lines are not a function. So vertical lines, not a function. All other lines actually are functions, by the way. So any other line, horizontal, slanted, positive or negative, it doesn't matter. They're all functions, but vertical lines are not because it fails that vertical line test. And then the last one we'll do here are equations. Equations can be pretty tricky. So same question, is it a function? Now for our purposes, we're going to keep them relatively simple. So let's say y equals x, y equals 2x plus 1, y equals 5, and x equals -1. So when you have equations, unless you're really good mentally with like visual pictures, these are great just to graph. So I would even just take out some technology here. I really like Desmos. It's one of my favorite calculator apps. For instance, if you haven't seen it before, let me just bring it up real quick for you. It looks like this. So there's a website for it too, also called Desmos. It's a little hard to see on the computer screen though right now. I don't think I can get it to. Let's see if I can just move it up for you guys. Oh, there we go. So you can see it is a grid and it's really easy to work with. Like I can just type in my equation, y equals, let's say 2x plus 1. And then it'll just graph it right here for me. And it's nice because if you have a touchscreen phone, then you can go ahead and, touch along that line too, and you can zoom in and you can zoom out. So this is called Desmos. You can see the name. I'll write it down. So Desmos is a nice graphing app that you can use, and you can use any graphing calculator you want to. But if you're getting stuck on equations, like I said, even for domain and range or for is it a function, you can graph it, and sometimes they're much easier to determine visually, right? Like I could use the vertical line test here. Or I could think about what's going on. So what we just mentioned is that all lines are actually functions unless they're vertical. So if I look at this example here, if I were to graph this, this is actually just an increasing line. It has a slope of 1 with a y-intercept of 0. This is going to pass a vertical line test. If I graph this one, this has a slope of 2. It's positive. It's going to be increasing with a y-intercept of 1. So again, it's going to pass the vertical line test. This one here, you have a horizontal. I haven't seen one of these. We haven't done one yet, but if you do vertical lines through it, it always passes the vertical line test. This is the one you have to watch out for lines because you have a vertical line here. So this one is not going to be a function. Now, for more complicated examples that aren't just linear, you really have to visually think about what is going on here with this equation. Is there a way for me to plug in one x value and get two different answers? So that is when it gets a bit more complicated. So this is a little bit advanced for us, but just to kind of see an example here. Well, let's see. 2y squared. All right, let's do y squared plus x equals 4. Now, again, this is much more complicated. This is not linear, so you don't have to worry too much about this yet, but I just want you to see what happens. So here, my recommendation, if it's an equation that you're not familiar with, is to graph it, and then you can use your vertical line test. Okay, so that's always one strategy, and that's a great strategy. The other thing is you'd have to just think and kind of try it out if you don't know how to solve an equation like this. So for instance, if x was 0, then what would happen is I would have y squared plus 0 equals 4. and y squared equals 4. Now, if I think about this, well, if y was 2, that would work, right? Because 2 squared is 4. But if y was negative 2, that would also work because negative 2 squared is also 4. So here's one that is not a function, that is not just a vertical line. So again, my point is that you don't have to stress too much about this just yet, but there are other examples that exist that are just, they're not vertical lines. Like circles, for instance, are not functions. Ovals, here's an example. Like, so there are other things that are not functions. And if it's a picture that you're not as familiar with or an equation that you just don't know how to solve, I do recommend graphing, and then you can always use the vertical line test on those equations as well. Now, let's say that you already know that something is a function, all right? So we've made it past the point of, is it a function, is it not a function? So let's say, we know that y equals 2x plus 1 is a function, right? We know that it's a linear equation that's not vertical. We've done the vertical line test and graph this, whatever reason is, but we now know that it is definitely a function. So what we do is we use what's called function notation. And in function notation, you switch the y for typically f of x, but you actually can use any letter. It could be g of x, h of x, t of x, it doesn't matter. But we tend to use f the most commonly because f stands for function. But anything that looks like this is function notation. So what happens is instead of writing it like this, you rewrite it like this. So that y gets replaced with f of x. Now, a lot of students get really confused by this. I will say that you are not multiplying anything here. This is not f times x. I know we're so used to parentheses being multiplication. It is not multiplication here. So you're not multiplying like everything by x. Don't do that. It is a way to let the reader know that, hey, I am a function. I behave nicely. When you plug in an x value, you get one answer. It's sort of like the idea of going to the doctor's office, right? When you go to the doctor's office, we say doctor right in front of the person, so that like acknowledges to the entire community, like, hey, this is the doctor, right? So like, oh, hi, Dr. Smith, or Dr. Jones, wherever it is, and it lets the person who's in the room know very quickly that, hey, this is the doctor, right? Same thing for teaching, right? If I walk in and say, I am Professor Pollard, you guys know that's my instructor, right? If I just come in and say, oh, hi, I'm Mrs. Pollard, we obviously can have a conversation. I can explain to you that I am your professor, but it's not as clear, right? So that's all this is. It's letting the reader know that, hey, I am a function. You don't have to check it. You don't have to worry. We're telling the reader that this is in fact a function. And the output you get there is still a y value. So function notation and y are totally interchangeable. They go back and forth between the two. And that can be, confusing for students. So it is the same thing. It's something to get used to. Also, we do read this as f of x. Or if you use different letters, you could say g of x, h of x, etc. So that is how we read it in English. Or you could obviously you could say function of, but we usually say f of x. So formally, y is a function of x, but most of us just say f of x for short. All right, so how do you use this function notation, right? So let's start with this here. Well, let's say I want to plug in different x values, right? So let's say I want to evaluate this function. It would look like this instead. So let's say you got a question that said, hey, what is f of 3? Now you may think to yourself, oh, I'm multiplying everything by 3. You are not. So what this means, when you see that number in parentheses, it says, hey, plug in 3 for x. So what you're going to do is you're going to take the equation here on the right, and you're going to replace the x with 3. And then you'll do whatever it tells you. So here, I would do 2 times 3, right? 2x is 2 times. So that would be 6. So I have 6 plus 1 is 7. So I get f of 3 is 7. What if I want to find f of 0? Well, I'm telling you, say, hey, you're plugging in 0 here. So I would take the right side of that equation. I would replace x with 0. So again, that value inside the parenthesis is your x value. It's also called the independent variable there. So, and we get 1, and I see f of 0 is 1. Or let's do one more. What if I want to find f of -5? Again, we're telling the reader, hey, go ahead and plug in -5. So I do 2 times -5 plus 1. Well, that's -10 plus 1 is -9. So what happens here is this number on the inside is your input or your x value. That number on the outside is your output or your y value. The interesting thing is that these are still points. So for instance, I can also write this as the point 3, 7. So, when you know f of x is equal to y, it's the same thing as having a point x, y, and you can go back and forth between the notation. So by evaluating like this, you actually can get all these points that you can later graph. For instance, here, again, this is your x value. This is your y value. So if you needed to graph this, you could also write these as points. So it's good to be able to go back and forth between the different notation. Okay, let's do one more example. All right, so let's do something a little more complicated. How about all right, so here it says h of x equals x squared plus 5. So where it's in function notation, you know that anytime I plug in an x, I'm going to just get one answer. So I'm telling you it's a function. Again, we do switch letters sometimes. It's for the same reason that we don't name everybody the same name, right? I have 3 different children. If I wanted to name them all the same name, I don't know, let's say Susie or something, I could, right? But it would make my life really complicated when I call, hey, Susie. So what we do here is we often use different letters for functions so that it just makes it easier for the reader to not confuse that, these are different equations that we're working with. So let's say I wanted to find, how about h of -4? So this is going to be my x value. I take my equation here, I replace the x with -4. Just be careful you are squaring that, so the negative will square as well, and you get 16 plus 5, which is 21. So h of -4 is equal to 21. And again, if I wanted to graph this, I do have a point right there, -4, 21. The value inside the parentheses is x, and the value outside is y. Let's just do one more. How about h of 0? So we would go back to the original. I would do 0 squared plus 5. 0 squared is 0, so this is just 5. And h of 0 is equal to 5. So again, there's your x, there's your y. If you wanted to graph some points after this, you could write them as 0, 5 instead there. Okay. And if your example had more than one position for x, so maybe I'll just do one more, I would stop. Let's say you have something like this. How about g of x is equal to 2x squared minus x plus 3. Maybe I want to find g of -1. Well, if I have more than one x, I just plug it in for all the x's. So for instance, I would do 2 and then -1 squared minus -1 plus 3. So I'm taking my value here and I'm replacing it anytime I see an x. So it gets plugged in for both of them. And then you're following the order of operations. So here we know that that is a 1. My negatives here will cancel. 2 times 1 is 2. So I have 2 plus 1 plus 3 is going to be, let's see, 6. So g of -1 is equal to 6. Now, one last thing you can do, and again, we don't do this as often, but let's say, I'm going to go back to an earlier, simpler example. Let's say instead you had a question that asked you to find something like this. This is different. And again, we don't do this as often, but notice here that I did not plug in the 4. I had it as equal 4. So what's happening in this case is they're telling you what the Y value is, or the output. So in a case like this, when the value is not in the parentheses, what you would do instead is you would take that equation and instead set it equal to 4. Just like it says here, set it equal to 4. And then what you could do is you could solve that equation using our regular solving skills and work backwards to find the x. So what I know is that f of 3/2 will give me 4. So there's my x, there's my y. Again, we don't see that as often, but I did want to point it out to you in case it does come up. If the number is outside the parentheses like an equal, then you're actually getting the answer instead of the y value or the output. So you're working backwards to find the input there.